I'm Hyein, based at the University of Sydney. So Elaine already gave a great overview talk about ASKAP project. Thanks. And I'll be more focusing on the ASKAP-FLASH project on behalf of the FLASH team. So FLASH is a collaborative work done by many people, and the survey is led by two PIs, Elaine and James Allison. And it's the first large absorption survey in H1, searching for H1 spectral lines from the intermediate redshift range, especially out redshift 1. So now the survey is at the final stage of pilot survey 1 and preparing for the second round of another 100-hour pilot survey. So during the past year, the team has been actually more focusing on data processing and validation and putting a lot of effort on it. But at the same time, we were able to get very intriguing detection from the sky. So now pretty much ready to go for doing much deeper science. So today I'll overview the current status of the survey and present the very first result we could get from the pilot survey 1. So FLASH is a wide field untargeted H1 absorption line survey using background radio continuum sources with ASKAP. So it's an untargeted survey. So basically, we don't know where we can find the absorption line from, which is exciting. So whenever we detect an absorption line, and if the lines are confirmed as real, the next step of us is to collect the information from the line itself and from all the archived multi-wavelength data as much as possible to trace the origin of these lines. So FLASH is the first unique survey set to study of the H1 content of individual galaxies in the distant universe, which hasn't been studied well properly before. So it's toward the whole southern sky, and the ultimate goal of the surveys are, we aim to trace the evolution of the cold gas in galaxies. So what we do is observing the entire southern sky and extract the spectra toward the radio sources in the low frequency band with ASKAP. And it doesn't target individual sources. Instead, we observe some selected fields and detect any absorption line from there in the redshift range from 0.4 to 1. So we will eventually cover about 34,000 square degree of the sky. And we roughly expect the numbers of detection as a function of the observed frequency. We expect to see roughly about 1,000 H1 observer from the sky area. So a little bit background of H1 absorption study. So H1 lines, both emission and absorption, come from the spin of the neutral hydrogen atoms and good information of interstellar gas. But H1 emission line is weak to be detected at higher redshift. So with the large telescope today, especially with connected radio array to date, so we can only detect H1 emission out to redshift 0.4, and we still need a huge amount of observing time to observe that. So there is a strength of H1 absorption observation in this aspect. So if we observe H1 absorption line, the sensitivity is independent of the redshift. So the detection limit is only determined by flux density of line of sight background sources. So there are two types of absorption we can expect to observe in this survey, as you can see from your right-hand side. So one is intervening absorption line due to background radio sources, and the gas is located in between radio source and us. And another one is associated absorption line, which is directly related to the host galaxies and AGN. And these are good targets to understand the key physical process inside the system. So in the middle panel, you can see the H1 content as a function of the redshift, and FLASH will contribute the redshift range in the red box, roughly 4 to 8 giga-year lookback time. So the pilot survey 1 we have been working on is based on the observation using all 36 completed antenna of the ASKAP. So the key advantage is it's been built in radio quiet side, as Elaine mentioned, and it has a long 300 megahertz bandwidth and no RFI significantly in this frequency range. And it has a wide field of view, which is 36 square degree in a single point. So we have already completed successful early science with targeted quasars before starting the pilot survey. As you can see from your right-hand side, there are striking intervening absorption example we found from gamma 23 field. So based on these kind of things, we started pilot survey 1, and like other ASKAP surveys, the pilot survey observation has completed early this year. So it covers about 1,500 square degree and observed for 100 hours. So the aims of the pilot survey 1 is to test and validate observation and data processing strategy for the full survey. So specifically, we will measure the detection rate for associated intervening observers using the largest database. And another thing is, it is a very crucial step to validate our observation strategy and data processing pipeline before going to full survey next year. So the plot on the right shows the field we selected. And these fields were selected because there are many available multi-wavelength data based on gamma, swan, and darkness survey. And this is very useful to confirm if our absorption features are real or not using multi-wavelength data. And the frequency range is roughly from 700 to 1,000 megahertz. And it covers the redshift from the 0.4 to 1. So for the pilot field, we finished our pilot observations early this year, and the data pipeline test and quality data validation are underway. And now we found some detections from the cube, and we have been preparing for the papers, especially the sub-survey description paper will soon to be submitted. And this is very brief summary of data validation process we have to do when we have new data. I'm not gonna go deeper, but this is one of the very crucial goal of the pilot survey I would like to highlight. And on your right-hand side, this is a summary of the OR field. So what I'd like to highlight here is the RMS noise level is uniform across the entire spectral band, and also in the continuum images, and across the different array deck and observation time. So now let's move to the latest preliminary result of the survey. So these are some new detections we found from the pilot survey observations. So FLASH is an untargeted survey. So these lines are from the random sky area. So the red arrows are pointing where the absorption lines are found. So some cases show optical counterpart near these redshift, but some cases don't have any optical counterpart, so they are likely to be intervening observers requiring further information. So the expected RMS is a few millijansky level per channel, so which is consistent with measurement. So especially these samples have been confirmed with online finding tool called the FLASH Finder run by James Allison. So far, most are confirmed as real lines, and they are related to luminous red galaxies directly or indirectly. So here is a more deep look at one of the examples, a strong intervening observer candidate. So in the middle, you can see the full spectra we can get from the cube. And the great thing here is we can get this large band spectra at once. And there are some artifacts, but no significant RFI and very stable baseline. So you can see clear detection on your right-hand side. The MVS is sourced at redshift of 0.4, and it has a relatively high peak, 21 centimeter optical depth. And H1 column density is above 10 to the 21 atoms per square centimeter. And it is located behind the foreground star, so hard to say, but deep imaging with DACAM suggests it can be related to a red object, which is off-centered from the red source sight line. So we hope to get some time to provide strong constraint on the position of these intervening source. And another one is PKS source, which is one of the associated observer candidates we found. So unlike the previous one, it has optical counterpart, and the optical image shows a faint candidate for the observing galaxy. So it has a peak optical depth of 0.04, and the line is unusually broad for this kind of H1 observer, suggesting that it could either from the cold gas in the host galaxy or multiple sightline lensing effect affect this kind of wide broad line. So, but further data for discussion is required. So then lastly, in addition to the spectra, another great thing is we can get high quality wide field continuum images at the same time. So the images here is to show some of the continuum images we could get from the pilot survey observation. So most continuum images generally look great, and the RMS is roughly 100 microjansky level, which is roughly 5 times deeper than MVSS. So this is zoomed in the images. So the main goal of the FLASH is on spectra, but our high quality continuum images are enough to find intriguing radio sources. So it allows us to extend our work. And we expect this is a good synergy with other multi-wavelength imaging. And the good thing is FLASH covers some sky area which hasn't been reached by previous all sky survey like MVSS or FIRST before. So I will just leave my summary here. And we are at the last stage of pilot study 1 and already find intriguing observation lines, and now preparing for pilot study 2. And I believe there must be more intriguing science cases to come. So I will stop here.
All right, thanks, Hyein, for that nice talk. In the interest of time, we could probably take one question, but feel free to post some questions on Slack and Hyein can follow up with that. So I don't see any questions or raised hands. Oh, there's actually one by those who. So there's a question. Those are some really cool galaxies you showed on slide 11. Do you know what redshifts these are at?
You mean the 2 examples?
I think it's on slide 11. Yeah, these ones on 11. Then, yeah.
11. So most of them are not identified from any other multi-wavelength studies. So most of them not identified redshift. So we should collect more information, but we don't know actually.
Okay.